Alright, we are here to do a new 4coder Friday. In this 4coder Friday series, I am going back through 4coder codebase stuff and reviewing what I see. If I see good stuff, I'm pointing out what I like about it, where the ideas came from, and if I see bad stuff, I'm explaining what's bad about it and what can be better. Um, Last time was our first one, and we looked a lot at the build system, touched on the base layer, although I think the base layer is one that should probably get a bunch of attention over time. In general, we did some basic stuff with the base layer. The um, the thing I want to look at today is the website. So I went and updated the 4coder website. The security certificates weren't working. It was on an old web hosting system. So I moved it onto a new system since last Friday and made a few tweaks to make the page more accurate again. And the documentation is all up and running and stuff like that still. And in the process, I discovered some issues with the 4coder codebase. So that already happened off stream, but it gave me an idea of where I want to target my attention. I also want to remind you, just like any of my other streams, this is a project from the Mr. Forth Lab. So if you go over to mrforth.com/membership, we've got cool perks that you can get for becoming a supporter or a member. There's monthly and yearly billing options for that. And it helps to keep all these projects going. This is what I do instead of subscribers on Twitch or YouTube memberships and stuff. I've got my own system because I want to give you all kinds of different rewards that I rolled up myself. So go check out mrforth.com/membership and consider joining up there. Now let's talk about 4coder. So I have 4coder. Let's look at the code folder for a minute. 4coder is organized in some strange ways, but the code folder contains all the code, and that includes the core sort of, I don't know what you call it, engine/main application code, which is all of this stuff here. And then there's these folders for different platforms, folders for the custom layer and other layers. And there's also this folder for the click bug. There's also this folder for the website. And the way the website works is I have a couple static files that I write by hand, or that someone wrote by hand. I don't think I wrote the search system for the 4coder website. And I have this render main.cpp, which is the target for a C++ program that renders out the documentation pages and all the other generated pages. I think they're all documentation pages, but it renders out the generated stuff for the website. And if we look at our project file for 4coder here, the 4coder project file has this build site render build. It's on F3. So if I do this, that's how we build the site render main.cpp. And you can see we got a compilation error. So this is what I found when I came to work on the website. Is I have render main, site render main.cpp doesn't build. So I'm trying to update the website, trying to get the files, and the renderer just doesn't build. So why was this left in a broken state? This is bad news. It shouldn't be left in a broken state. So my first question isn't how do I fix it? My first question is, how did this happen in the first place? Why would I leave it in a broken state? And if we go and look at what's broken, it's saying this function doesn't exist. Make arena system. So what is make arena system? Well, first of all, it's a funky naming scheme. It means make arena using the system version of the arena. So if we look here, system allocator, make arena system. There it is. And you can see it involves getting the base allocators from the system and this. So we're not going quite into the complexity with arenas today, but notice that system allocator.cpp sits right here, and it should just be able to work. So why doesn't it work here? Well, first of all, the main site itself is relying on some of the code from 4coder custom. So 4coder custom includes this command map stuff, and we want that command map data structure because part of what we're rendering out in the documentation on 4coder is the command documentation, right? We've got all these commands, so the commands themselves get rendered into documentation, and we have built-in bindings, so we can go and look at like what are all the bindings for 4coder, right? And in order to have the data structure to render that out, I need to run the same code, right? 4coder was customized by writing C and C++ code. So the bindings live in C and C++ code primarily, and so in order to extract the information about that bindings, what I need to be able to do is compile and run the code, right? That's how you get at the data. So that meant that this data structure had to work as a part of the site rendering, and those parts of the main code base, the rest of the code base that involved setting up this data structure and filling in the default maps, that all has to compile as part of this. So command map.cpp is included into render main.cpp, right? But why doesn't it build? Why doesn't this work? And the answer to that is, well, this is actually using the malloc allocator instead of the system allocator. And this has the function make arena malloc. So in order for this to build, I'd have to go make arena malloc here, and then it would work. But then, whoops, let's see. So the website, then it builds. But now the main build is broken because in the main build, we also need command map, and we need that one to use the arena system. I got a question in chat. So Tool is asking, is the R quote thing to do a multi-string literal? Yeah, that's what it is. So this is C++, I think it's C++ 11 and later has this. The syntax is R open quote, open parenthesis, right? You go R quote, parenthesis quote, and then as much string as you want right here. And the parenthesis is not in the text. And you can also add in, you can make the delimiter more complex by going like foobar, and now you have to put the same delimiter on this side to make it match. And that way you can have open and close parenthesis quotes all over the place. And that's the reason for all that is so that this can also include doing things like right? If I do this, I don't want this or this to delimit the raw string. That's the idea. Okay, so what we're talking about with the command map, though, is this thing here doesn't work. So what are the mistakes going on here? One is that there are two different names. In some contexts, I am building, and there's the the system version of the allocators, and in other contexts, I'm building as the malloc version of the allocators. So that might be confusing, and let's actually take notes along the way about the different mistakes that come together here to make a problem. Oh shit. Let's see. New Milton canvas. Wait, did I make a 4coder Friday one? I did. Yeah, let's do this one. Okay, cool. So we have the system allocator and the malloc allocator. And and we have a layer on top of that of system arena. And notice there's no abstraction here. System arena and malloc arena cannot be constructed in the same we can't write a piece of code that would choose one or the other based on what's available in the context. So we either have this in context, right? Or we have this in context. We can't have both. Well, we can, but whichever one we have, whichever one we're using, we tie to directly, right, from the calling code. So that's the setup. Now, first question is like, why is it this way? And the answer is the system stuff is baked in a funny way. So let's go look at the system allocator. And if we keep digging here, we're going to look at get base allocator system. So what's happening, and I don't like this anymore, this isn't how I do it, but I used to make a sort of a virtual table struct with all of the different, we've got reserve memory, commit memory, decommit memory, release memory, and also memory protection flags. So we have 5 function pointers that describe system level virtual memory management. And those go into a struct. And for the malloc version of the allocators, we have a similar table, the malloc allocator. That's a very basic one. We just make reserve do malloc, we make release do free, and the others are irrelevant. They don't do anything, right? But the system version has to call to system memory allocate and system memory free. Weirdly, that doesn't seem to have a reserve commit decommit release. It just has reserve and free as well. Just strange to me. System memory allocate. It might have been that my arenas weren't even reserve commit arenas back in this time. Dear God. Okay. Whoever was working on some of the 4coder Linux stuff was obviously not using 4coder because this layout's all goofy. But that's okay. I just want to see, yeah, so you can see system memory allocate lives here in Linux fored functions. And Win32 fored functions itself also has, should have Unix sysmem allocate sig. Where is system memory allocate, system memory allocate, system memory allocate, Unix fored function, system memory allocate, system memory allocate, Linux fored function, system memory allocate. So there's one of these defined for Linux, one of them defined for Unix with a macro that doesn't seem to be getting used in a lot of other places. See how they're like all totally differently shaped and I can't even find the definitions? System memory allocate, system API. Hey, Batman. Nice to have Batman in the stream chat. Okay, system memory allocate. What am I missing? Here we have memory allocate, memory set protection, memory free. Let's go to base. Yeah, this says it has reserve commit, uncommit free, set access, and user data. But like, when do we ever use all of those. I just think we don't. Like, it's just... I don't see any sign, get base allocator system. Okay, so the point of all of this is to say... Oh, thank you. The point of all of this is to say... It's just really messy. There's, like, a lot of problems here. I can't quite easily see how I would untangle this. So I don't even know still, while I'm looking at it, where we're doing, like, where is virtual alloc? I have been searching for it. Where do we define Win32 memory allocate extended? Okay, and why is that a thing? System memory allocate sig. Okay, so this is the trick that I've been missing. System memory allocate sig makes the definitions on Windows and Mac, but not on Linux. Again, weird. They're not in parallel. The maintenance has not been done correctly. So everything here is... just quite a bit off. But, okay. Ugh, okay, so the point here, I'm getting a little lost in, like, searching around the code looking for where it all makes sense, and it just doesn't. There's so many messes, nothing's organized. It creates a lot of problems when you're trying to actually go through and see what things do. Point is, if I try to build... Wait, do we not have... There we go. If I try to build, this doesn't work. And I can't just include the functions for the system allocator. I can't just include system allocator, because look what happens. If I come up here and say, hey, malloc allocator is actually the wrong one, let's use system allocator. And we go, okay, so the main program builds, and the website builder, oh, system memory allocate, identifier not found. Okay, so now the problem is we can't actually, and I guess there were other spots here that were directly tied to malloc as well. But system memory allocate can't actually be found, and the answer to why we can't find it is that it gets defined in something like Win32 4head functions system memory allocate sig, right? And so this would mean we'd have to include Win32 4head functions.cpp, but only on Windows. If we wanted this to build on other platforms, we'd need to include those. And so the question is, well, how are we handling that? Like, where's the codebase's solution for having a program run on multiple operating systems? Doesn't 4coder support that? Why shouldn't it work? Well, the answer is it doesn't work because the platform layer's only way of sort of tying in platform layer specific stuff is sort of handmade hero style. Now, I've had this conversation before with people online, and I'm not trying to throw shade at the handmade hero approach unnecessarily, but I don't quite get how it's supposed to be convenient if you actually need to maintain multiple programs from a single code base, unless you start to change it a little bit. So the handmade hero approach to a platform layer is to write a main function, right, that does all the main work of setting up the program, and then have that function call into the application specific code. So like app dot, what do we got here? We've got app dot load vtables, get the logger. We're handling the command line. We're initializing the main program, and we're doing the frame step. Great. So that's nice, but that means that the only way to get at the operating system abstractions that I've built in this code base is to also bundle in this particular main, the one for the main program, right? The 4coder itself. And so to get to a point where I actually could use my allocator abstraction for rendering the website, I would have to refactor that. I'd have to say, hey, we need a platform abstraction that actually exists prior to main, that exists independent of what your main is. Because sometimes I want my main to look like this instead of like this, right? And not just the difference between main and win main, but literally I want my main to be this code sometimes, and I want my main to be this code sometimes. And if I'm going to need multiple mains within my code base, which you are going to need if you're building a project, right? If you're a programmer building a project, you aren't just shipping one software, right? It's not about getting the code right for a piece of software. You have tasks to do, websites to update, processes to run for manipulating, if you're making a game, like asset data, pipeline stuff. You've got the main game. Sometimes you have multiple programs, or the main program. Sometimes you have multiple programs that need to interact, like if you have a server client system going on, right? There's often more than one program. Sometimes you have debug stuff. Sometimes you have tests, right? You have all these different programs that need to run. And each of those is a different main. And so the handmade hero way of bundling the main in with all the other platform abstraction stuff leads to problems that I did not find it easy to fix with the way I was doing it. Now, that doesn't mean they're not fixable. You can use this approach of having WinMain implement this, but I have found that I prefer to have one main for the application. I no longer do the separate main for each operating system, except to make, like, you know, if I want a win main versus a main, I might have a switch on which one I do. But either way, those are just sort of entry point wrappers to call into the same entry point for all versions of the application. And a good reason for that, let's go over here to the Linux one, look for its main function. You can see I got real cursy in a lot of the comments in these days. But like, there's this whole thing now of like, well, on Windows we do logging startup, initialize thread context, logging startup. Where is it? Logging. Oh, it doesn't exist on the Linux version. The Linux version and the Windows version behave so differently in this part of the code because they are maintained separately, and because they have different sort of orders in which they got set up and the way things were available between them. So there are spots like right here where you can see it's very much in parallel. In fact, there's literally comments left over from the copy paste, right? You know, we got loading the core and so on and so on. But again, this is code duplication. This is variance in the behavior of the program across operating systems. And this is the inability to build multiple programs that all use the same operating system abstraction. So the point here, if we go back here, the problem with this, the reason this was no bueno, only use the code base's operating system abstraction from the fored builds. Other programs had to, let's say other programs, and it's not just the web stuff. Here's another example of the kinds of things you have. I mentioned tests, I mentioned asset baking. There's also meta programs. So it leads to this problem where I end up needing to rely on a separate layer of utilities that is CRT based instead of uh, operating system abstraction based, right? It doesn't go through an operating system layer. So this whole conundrum was my inspiration for the base layer and OS layer. Right? That's what I learned from this mistake, was that I actually need to build up my code base with a base layer that goes across the whole thing, and that I need to have my operating system abstraction work across multiple programs within the same code base. And once I can do that, well, from that you get these two original playlists, the code base, base layer, and OS. At this point, I build that as a single. Oh yeah, we're not in the Mr. Fourth code. That's right. At this point, by the way, just to catch us all the way up to the modern iteration of this, I now build all of it, and it's not done. I'm still iterating on this, but I now build all of that base layer and operating system abstraction into a single Mr. Fourth base.h and accompanying .c and some other like tied in files. Okay, so render main. So another thing that happened here was that the reason this didn't, so this is one of the reasons why, let's label everything we're doing. Why the website render stopped compiling. Okay, so this is reason number one. OS layer is not reusable. Okay. There's another problem, which is the only reason we ran into this. Let's see, build. So let's see, get this back to its original state where it actually works. Make arena system. So another reason that we hit this is that we needed to use code that lived in two different programs simultaneously, right? Command map needed to live inside of 4coder's main default custom layer, and it needed to live inside of the website render. So we have command map. We have website render. This would be better if I change color so that they go together. Noob Mind, hello. No, I don't develop 4coder anymore. We are reviewing 4coder. This is a 4coder critique show now. We are looking at 4coder and studying what worked and didn't work in the old one, or in the 4coder code base. Tool asks, what field of software do you have the most experience in, and have you ever done any game engine dev? Sorry if it's off topic. Feel free to skip. What field of software do you have the most experience in? At this point, I have the most experience in development tools. I know a lot about the native layer, base object files, binary files, compiling, linking, debugging, text editing. One piece of the tooling that I haven't touched yet is version control. But yeah, the creation of development tools has been my primary focus of experience, both in 4coder and at the RAD debugger, and now with Mr. Fourth Lab. I have developed a game engine on a couple of occasions, usually for here. I'll show you. I'll show off. We're taking detour to answer this question, a little more detailed than we need to, because I feel like it. Sometimes it takes me a minute to find. Here. So I developed this game on SFML in C++ years ago. And a few other game jams here and there. But it's all like small scale, hand rolled game engine stuff. I haven't worked on like big AAA engines or super high end game engine stuff. Like I've never done 3D, something I'd love to do someday, but I've only ever dabbled with the very basics. I need to do the real thing sooner or later in my life, but I still feel compelled to work on dev tools. I think we got a problem on our hands in the computing world that calls for my expertise, so that's where I'm putting my attention right now. So, what are we doing here? Somebody hitting a key accidentally or something? No. We seem to have lost touch with. Is there a button getting held down here? What is this? Okay, just gonna have to restart Milton. That was some kind of weird buggy state. Hopefully it goes back to normal. Reset my brush size. Too big. Too big. That'll work. Yeah, maybe I usually do it a little bigger and then I'm more zoomed in than this. Okay. Okay. There we go. Back to it. This is the forehead custom layer. Right, so I have two different programs. let's label these. This one here is a target. This one here is a target. And this one here is what do I call this? Just like a layer or a data structure, something like that. And so this situation is reason number 2. Using same data structure layer in multiple targets. And the thing is, when you put these two together, you get the build error, right? If I'm using the same structure in 2 different targets, but some targets are going to connect this way, and some are going to, and they have to, and some of them can't, then we get into a spot where it's not clear how you can ever write this code that's in this layer to work both ways, especially if you don't add an abstraction layer. So let's add that in as a reason number 3. Reason number 3, never developed an abstraction layer that actually solved the problem. So let's take a look at that part. I kind of did have an abstraction in 4coder's memory system. In fact, I had a lot of abstractions. If you use abstraction to mean extra layers trying to hide what was happening and remove detail and that abstraction was this, right? So the base allocator allows me to put in different kinds of base allocators. But it didn't work. Like I said, it didn't actually solve the problem. This is the idea of abstraction that you learn from C++ or Java or any other object-oriented language. It's the idea that an abstraction is a collection of functions that are to be defined later or to be defined in different ways depending on runtime context. That actually doesn't solve my problem, because what I have here is 2 different static contexts, right? I have a command map, which exists in render main, and it also exists in, if we take a look, command map.cpp, it exists in some of these other targets. It exists in the application layer, it exists in the default, and it exists in the default custom layer, right? So I drew a picture with 2 overlapping targets. Turns out we actually have 3. Custom layer and app layer both touch command map. Not surprised. But some of these contexts go to system allocator, and so we have make arena system. And yes, I have an abstract runtime abstraction for allowing me to put in arenas types in different places and have them work regardless of whether they're backed by the operating system or by malloc. But that's the opposite of what I needed. What I needed was the ability to use the same name, right? I needed a place where I could go make arena, like right here. I needed the ability to go make arena and have that line successfully make an arena whether or not the context of the compilation, statically, the static context, had access to operating system abstractions or malloc. So the real way to abstract this is not a runtime abstraction. What I really needed was a compile time abstraction, which would look something like this if we were to spell it out. So we have system allocator, right? So we have 4coder system allocator .cpp provides things like make arena system. We have things like four-coder malloc allocator .cpp make arena malloc. And we would need something like 4coder allocator.cpp that could then go if platform layer available, then make arena equals make arena system, else make arena equals make arena malloc, right? We would need something like this. And I don't have that, but this would be the static version where you say we're going to make a symbol that is known statically that can have different meanings depending on the static context. That's a static compile time abstraction, and C++ and Java don't make you think that way about abstraction. That's actually what I needed, and that's what I was reaching for with things like the base allocator, and I couldn't quite at the time figure out why it wasn't clicking, and now it's so obvious to me that this is runtime abstraction, not compile time abstraction, and so knowing your types of abstraction matters. Okay, I think with that we've covered the main reasons why, right? So this was right here. The third reason why we did not get a better story, and why the website didn't compile. So I think that covers the website part. Let's take a look into some new stuff now. The base types. There's a lot of stuff here. I think we've kind of been over this recently. Let's see. I'm going to just start from Win32 4ed CPP and kind of go from there for now. Okay, so we can start to see some things I don't like. So like, I keep mentioning that this code isn't organized, and that might seem like I think for some people disorganized code is just like the norm. Like it's like, yeah, but like that's what code looks like. This is the deal. And the thing is, you can put in effort and make it organized, and that does make a difference. So let me show you what I mean. This is some function declarations. Why? Why is this here? Well, presumably I'm going to call it. No calls. There's just definition. Okay, now I'm calling it, but I'm calling it after the definition. So I don't know why that got forward declared. It looks like we could just eliminate that and it would be fine, unless there's like a function pointer or something. Maybe output error string will be different. And nope, we define it first and start using it. So it's a little weird because I've got here in my C++ file, in the CPP file, I've got structs, I've got function declarations, and in order to figure out where everything's at, you kind of have to start scrolling to like some includes, and then there's these things, and there's some structs, and then there's some includes, and there's some more types. We get to win32 vars is like, okay, here's a function definition. Cool. What's this function for? Does it get used? Yeah, it gets used as the error box function in the main API. Cool. So it connects out from outside of the platform layer, and it gets defined here. Where is the spot that I define the system error box? So system error box. Where is? When do we generate system API.cpp? That's my question. Not when we include it. When do we define it? Weirdly, I'm not finding a definition for... There's like, we must have generated this. Where is the generator? It might have been a generated once kind of thing, or it might just be hand maintained, I suppose, but it's living inside the generated folder. Right, if we go to generated... Oh, it's not. Florid System API. Okay. Here we go. Define API. Florid System API.cpp. Where does that factor in? Build one time. API definition main. Okay. Okay, this is nonsense. Just gonna call that out. Let me explain in a minute. Okay. So, API definition main has the main entry point, and it has these two forward declared functions here. They'll actually already be no, yeah, they get forward declared here, and they're expected to be defined by the rest of the code. So this little bit of code here gets us started, and then we create the final version of the target by providing these two things. Seems cute. All right, so the target is an include of the main plus the extra things you need to fill in the data. And then whenever you update the system API, what you would do is you'd come in here, you'd modify the strings in this file, and then you'd hit a button, you'd go build system API, right? So I could go, okay, you know what? We're actually changing error box. It's also going to have an int code from now on, right? And then you go build system API, and it builds this. And if you look here, build system API is compiling this. Man, complicated build scripts all the time too. So yeah, it builds this. When do we run it? When do we run one time? So I guess we gotta go run one time. And there it generated these files, right? So if we go to system API.h and look what it looks like now, int code shows up. So there you go. That's how I maintained all these X lists and, or like all these things, right? All these defines for the signatures and the type defs for the function types, and the v table for all of the system functions, and the link API, all of this, like all of it gets generated from this, right? Now, that's cool and fine. Like, I like having a system like that. These days, what I would do would be a little different. Yeah, let's talk about this. So, all of this is constructing these calls and then putting information on each of the calls for parameters. And, well, what I can't help but think is, like, what about an X list, right? Like, what if I did this instead? How would this work? And this is close to doing the same amount of work. It's not exactly the same amount. It's a little bit less useful. And I'll show you how. In a second. Okay. So there's a couple of examples. So instead of writing all of this, all these lines for all the parameters and all the extra things that get passed through, an XList just pulls it all together like that. The only downside is that if you wanted to know the names of the parameters, and if you wanted to, like, separate out the type strings for each one, count the parameters, this is a little less useful than this, right? This bundles the parameters up into one spot, whereas this spells them out. Now, what I'd be curious about is, and we know we have, let's see a little more about how I maintain the API stuff here. Get call. Yeah. Couple other places where it gets used: font API, graphics API, custom API. Now, weirdly, this one is generated. Who is generating the custom API constructor, I wonder? And a system API constructor. Why is this a thing? Do you see this? Do you see how? Okay, look at this. People always tell me I'm too hard on 4coder, but, like, look at this. Okay, so I hand write this file over here. Right? And when I run it, yeah, it generates this. So if I were to do API system, build system API, run one time, great. Now I reload this. It's back to matching this. So what is it doing? It's creating an API definition called system. It's creating a call called error box with a void. And you can see it's now rotely using string u8 lit expr at each step. API call with location. The location string is empty. And then API param, char star, message. So that's all coming out from there. Why would I be generating something that looks almost exactly like what I hand wrote, is what I'm wondering. Like, why is this something that I need to generate? I don't see any sign of it getting called anywhere. I don't see any sign of it getting included anywhere. System API constructor just doesn't. So this is just a red herring. I don't know when this was getting generated, but it's not relevant anymore. Like we could literally go delete file and it wouldn't change anything. Custom API constructor. Okay, this one is getting used. And I do wonder why. Let's go check out on the 4coder website. Did the documentation ever include API documentation? Would it know something about like error box? No, it doesn't. So the thing is I've generated documentation. I wrote the documentation for the custom layer. Never got around to writing documentation for the system layer. Let's look at the documentation system that goes with this. Since we're generating everything all the time, you can bet custom API docs are going to be another one of these giant constructors that then goes through metaprogramming, code generation stuff. So, doc call arena cluster API definition. So we've got an API definition already. Global set setting, func, and then I fill that in here. Okay, so we begin the parameters on this. The function macro is just static. So as I'm going, I mark. I set up documentation strings, so like all of this exists so that when you look right here, you'll see things like setting, the ID of the setting to set, the ID of the setting to set. So to get this out, I put this in, and I also have to hand do the matching. So like what I mean is here I have so let's do custom API fored custom. Okay, where is this getting its API definition from? That's what I need to know. Wherever this is getting it from. Custom API construct. Sure, so this is where that's coming from, but where did custom API constructor come from? See how many stages there are here? Are we tracking this down? It's in the generated folder, but I'm not sure when it's getting generated. Tool asks, what's the benefit of static free functions? So the main thing is the compiler can optimize them however it sees fit without having to generate symbols for the linker. So if you don't have to generate a symbol for a function, you can eliminate it from the compiler, right? Like the compiler itself can just determine, hey, this was static, which means it can only be visible within this compilation unit, and I don't see it getting used. Or in the spots where it got used, I already inlined it, and so there's no actual need for a standalone version of this function to exist. And in theory, it can do even more stuff like that, right? So it just can optimize better. If it can't if it needs to generate a symbol for the linker, then even if it never gets called, it generates that symbol, and that symbol necessarily has to be a callable function. It can't be, an inlined version of the function. You can't generate a pre-inlined thing for later. It has to be a function call with the stack manipulation stuff. So it has to be a full-on function version of the function, right? A procedure call version of the function. And that doesn't necessarily mean that the inlining won't work. In the cases where it's possible to inline, it just means that that has to be generated, and callers to it have to, from other object files, from other compilation units, have to actually use the procedure call. It also is faster. If you create an object file with very few symbols, then linking goes a lot faster. I'm not sure how this got generated. Let's see. Doc custom API main. Custom. Where does the data come from for that? What's API master list? So that's all of them in one spot. Okay, so I think what might be happening is if we go over to the 4ed custom functions. Well, what is this? API 4ed API definition. API definition.cpp. No. Man, I can't remember what it's called. Does it not show up? So I don't think this is the output name. I think that's the input name. But I still don't know who generated it. Let's look at build super. Maybe build super is actually responsible for this. I don't see why it would be though. How? Okay. I can't figure out where my custom files are coming. I'm generating all these files. Maybe we should talk about metaprogramming next time. Maybe I should talk about it this time at this point. I mean, I've clearly made a huge mess of metaprogramming here. This is the only place where that file name shows up. It says it's being generated, but I can't find any generators for it. So maybe it got generated once upon a time and then I stopped. API implementation. This is what I was looking for. Okay. This is what I was looking for earlier. 4ed API implementation.cpp. Okay, so the API parser must be responsible. When do we build the API parser? API parser main. Script source file to load and parse into the output list. Blank API master list, there it is. So the reason we can't find it by searching for a string is because the generator itself is generating a bunch of these. So here's an important tip, very important. If you're gonna generate something like this, your generator's first step needs to always be to generate a comment that's like generated by, and then, you know, 4ed API parser or API, you know, 4ed API parser.cpp or maybe API parser.exe or something like that. You need to give some hints. You need to get some pointers back to where this came from. Artifacts. So there's things humans create. We create a text editor for a data structure like the text file and the file system hierarchy. The text editor works with that data structure directly in a way where we treat that as our direct interface, right? So it's not, there's no question where those come from. Those are the things we wrote. We made them. We put them there on purpose. But then if you have generated stuff, whether that's generated text files or generated object files or generated images, if those artifacts that you generate don't point back to the thing that generated them, then you lose track of how you got that, right? And this is why we have debug information. Debug information in executables serves this purpose. Generated text files need to do the same thing. They need to kind of have their own internal debug information that points back to the generator that created them. And the most rudimentary way to do that, very simple, line at the top, what's the program, what's the source code that did the work of generating this? Now, getting back into this, if I'm understanding correctly, what's happening is we are looking over all of our API definitions, and for each one, we set up some output file names. And then print those off, and then we generate output into each of those lit files. Now, I'll say it again, I wouldn't do so much heavy metaprogramming if I were to do 4coder again. All of this code makes it much harder for me to track down where these ideas are coming from and how they're flowing through. It is not trivial to find the mapping from inputs to outputs throughout this whole chain here. But basically, what's happening, let's take the tour. It all starts off in the API implementation. This one is handwritten. Contains API custom markups with C compilable functions. Then what happens is API parser main which is handwritten, loads forward API implementation.cpp, parses it, and generates custom API master list.h, custom API.h, custom API.cpp, custom API constructor.cpp, Now, all of that gets generated, and then we go look at the documentation. And you can see from right here that it's opening the generated custom API master list. So here we have fored doc custom API main.cpp is handwritten. It loads custom API master list.h, parses it, where is the output happening? Must be right here. Right, so this does all the work to construct it. Fill in all of that. Presumably, at the bottom, yeah, it just returns the information by putting it all into the cluster. And here it's just checking for full coverage and rendering the log. So I guess this doesn't generate anything. This is just a check. But there are a couple other places where doc custom API shows up. Shows up again here. Okay, so what's actually happening is that we have doc custom API checks full coverage. Custom API of custom docs. Then we have fored doc custom API.cpp and fored doc custom API star.cpp. These are handwritten. Bum. And what these do is these define the documentation data via these things here, right? These define our documentation data. And that And then we've got, okay, we're getting there. We're figuring out how all this documentation stuff worked. Okay. So that's not all of it, because doc custom API gets used as a function in a few spots. So it gets used over here in fored site render main.cpp. It's handwritten. It gets its hand on the API definition. Depends on custom API constructor.cpp. So it gets its hands on the API data structure differently than this. This gets it from parsing the master list. This gets it from running the constructor function. Who knows? But then it depends on and then it renders HTML from the documentation structures, right? So that's what this one is doing. That's how we get our site rendering. There's another place where we use doc custom API. No, not the definition site, not the site renderer. Doc custom API main. This is the checker. Okay, there's this one. Get custom layer boundary docs. What is that about? Well, that I can show you. Custom API documentation. Boom. So in 4coder, I can just go custom API documentation. I can say, give me the documentation for alloc buffer markers on buffer, right? And it pulls up a buffer with all of the documentation for that custom layer right into 4coder's buffer. How is it doing that? Well, 4coder has the ability to run in its custom layer doc API this, which constructs the custom API definition and then use that data for its own purposes. So it just calls to the core, hey, can you generate the documentation data structure for 4coder's custom layer, returns that to the custom layer itself, and the custom layer itself then uses that data structure to generate a buffer. So here in the fored API implementation, full circle implementation.cpp, which is handwritten, we also get, this is the second time we've referred to this file, implements get custom API, which depends on doc get custom API. And that allows the custom layer to render out documentation. So there we go. That is the system that I have right now. Now you'll see that there's, first of all, just a lot of stages. We have to first have the API implementation set up with these markers. We parse that out to generate all of this. We parse this out again to generate the same data structure. So when we parse this one, we get the API definition data structure, right? We can get that by parsing it from API implementation, and then we can generate all of these. We can parse the master list using the same parser to get the same API definition again, which is what we do in this layer. In this layer here, I'm attaching documentation. So I have API implementation. This CPP file is the source of truth. At the beginning of the chain here, this is the source of truth. We generate from that the various files. We parse those files again, or we parse those, either parse this file or we run this constructor to get that data structure back again. In this spot, we parse the master list and we mix it in with the documentation strings. The documentation strings are independent, right? They are not baked into the main source of truth. So they are a separate source of truth that has to be checked. So that's what we have this for. Number 4 does the checking of these documentation strings. Number 5 renders them into HTML, and number 6 renders them into 4coder. So this part and this part are fine. This part is only necessary because of the fact that the source of truth is separated in space from each itself. Right? If I have 2 sources of truth that need to agree, that's what the checking is for. This part is fine. This is like the way I chose to structure the input. This is a very heavy, right? Like at the limit, the simplest thing you could do is go global set setting. Global set setting is going to take this list of parameters. It's going to return this. Right, we could imagine a format sort of like this could exist somehow. And then we'd go, okay, and now the docs look like this. We could rearrange like this if we wanted. Right, so like this is sort of what we're trying to specify, and the thing is we could just write up a text file that looks like that and write a parser for that. Wouldn't be so bad. Right, we could even go like, this is the API custom. Then we do each of these, right? This could be the structure I had made. This could have been. I could do put the return at the bottom. You could have a little doc default rule for the app type or something like that, or we can go just leave it blank, and we could say the doc for the return non-zero when the setting is valid and updated without error, 0 otherwise, right? We could go related global setting ID. Now, upsides and downsides to this. What are the upsides and downsides? Well, it puts all of the definition and documentation in one place. Right. So that's cool. It makes it a lot harder to tell what the signature is. If this is my source of truth, if it was shaped like this, then what I don't have is I don't have B32 global set setting application links app global setting ID setting I64 value. Right, it doesn't, I don't have that. And missing that sucks. So the problem is parsing that is harder, right? And that's what I ended up doing here. So you get things like, okay, I want to write functions and attach documentation as I go. Let's mark it here, and we'll have, we'll have the marking be easy to parse, and then we'll parse out those parameters, and that will be the source of truth for the API structure. But then what we end up with is this thing where we're going, okay, so this lives somewhere in like real C source code. And then this is in some documentation source. And now we're separating these again. We're back to having to parse, right? So another option is, your code looks like this. Maybe you go, all right, let's put documentation like right in line like this. Maybe this can be easy. So we'll go documentation, and then we'll go brief, modify a core setting, param setting, the ID of the setting to set, param value, the new value for the setting, return B30 non-zero blah 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 blah, right? Related global setting ID. Okay, so if you do something like this, you're still writing a parser. You got to find this marker. You find this source of truth, which is readable C, and then you've got documentation right here. And you could, you could make it compatible with other, like an existing formats. So you could say like, hey, the format we want here is going to be like at setting, at value, etc. Whatever makes it easy to parse and is nice. But when you go to write your parser now, once you're done scanning to here, you're going to have to look for where's the documentation comment and like figure out how you format that, pull out these directives. So you can do that and pull out a source of truth that contains API structure and documentation in one bundle. It's still actually two sources of truth, right? If this names something like settings instead of setting, then this and this don't match. It can't link them up, right? So it's not actually two. It's not actually one source of truth still, but they are close enough to each other that it feels more like one source of truth. You still need a checker though. Ultimately, at the limit, there's no way to get this down to one source of truth in C without compromising too far, right? If you wanted to get down to one source of truth, start to look like this. And this is going to have a very similar problem to the first one we looked at with one source of truth that wasn't in C, which is we are now obliterating that function signature, right? Even if we get it to one source of truth that is valid C, we still end up losing the whole reason we wanted to parse it out of C in the first place, which was to not obliterate the function signature, which we've done now, right? Like, where's my function signature? I've got app, gap, setting, gap, value. So you could play around with this like this. You still got two sources, but nothing's perfect. So the question is, when it comes down to how to organize your documentation information, it doesn't fit into a text file. A text file, sometimes you want to just see your function signatures as code, as their structure that is about how they function within the source text of the program, within the source of truth that defines program behavior. But sometimes you want to look at them as how they are structured in terms of human interfaces that are more rich than a function signature gives you. And so documentation is like attaching more human interface to a function signature. And how you attach that is either you have one source of truth, which obliterates the other version of the interface, because a text file cannot provide two interfaces to its own contents. Or you don't obliterate the function signature in the code, you keep that intact, but you have a separate source of truth that needs to synchronize up. So you have to choose. Do you maintain two sources of truth and keep them in sync? Or do you maintain one source of truth that obliterates the typical interface slash function signature right? So it's an unsolvable problem if we don't get off of text files. That's the point, right? It's one of those inspirations for the exploration of new types of interfaces for constructing software in the first place, is that you start finding out things like this matter. You want to do them very well, and you can't do them perfectly because the data structure that we use to construct our interface for constructing software isn't rich enough to solve this problem. So, what's the compromise I would actually want at this point for something like this? If I was gonna try to fit it into a text file, I think I would do something like, we were kind of close to sketching it out. I would think I would do something like this. We would do, here's our function signature. Yeah, we got my preferred compromise right now would be, we go, here's the function signature. We're going to have to be able to parse that. So fingers crossed that we can succeed at that. And then we have something like documentation. Maybe there's like a end documentation. No, I don't like that. Let's see. Setting. Value. Deagle50 says functions are expected to provide a doc string. No? I don't know what you mean. What do you mean they're expected to provide a doc string? I'm not really trying to parse it. I'm just trying to think of what the preferred way to organize the documentation text is. Right, so I think we could imagine doing something like this for documentation, and it would add in a little bit of text in between each function of the main API, but it wouldn't be so bad, right? We would need, this would, so we have, this includes properties, puts, has two sources of truth, but they are locally near one another. Hey, good to see you again, or hear from you. And it preserves the function signature entirely. this requires C style function parsing for checking. So in order for this and this to be synced up with checking, we need the ability to parse function signatures, which makes us language bound. Question, I'm not sure I understand your question. Would you just parse it like the first function signature after docs end is linked? I don't know what you mean. Would I parse what like a function, first function signature? What do you mean by a first function signature? And what do you mean by linked? I'm missing the meaning of a bunch of those words, I think. Yeah. After you've parsed a docs string, you would just look for the next function and assume these two link together. That's right. So I think something like that. So that would replace. It would contain 1 and 3. So this part here. Source of truth for API structure and documentation information. We would need the document API and documentation parser. Which takes our source to some kind of API structure type. And then what we want to be able to do is we want to be able to we want API. Okay, some things we would have in the system are API structure would be something we could serialize and deserialize, right? Something like that. Now, if we wanted to, this could be a text mode serialization. Like this could be like this. But we would want this because then what we can do is we can run the parser to generate an API structure from the source. And then we can run the API structure to a data type and save that file around. If we make it a text file, it can be checked in. So maybe we make it a text file. And then what we do is whenever we want to use the API structure in anything else, all we need, right? So let's see here. That's no longer relevant. That got used up. So we need a checker, API and documentation parser performs, this is like this or errors, right? So this performs our checking and our parsing. Up here we have parser main generating this thing, and then separately API main checking the docs against the parse. So those two fold together, these two fold together. Then these things here, things like rendering the website, this would just be load the API structure. This is loading a data block or a text file and destructuring it, deserializing it using this piece of the system. And then API structure to HTML, right? And 4, we would have, if you want to have the ability to show this inside the main program, then this is application self-documentation. This just has bake API structure into application, API structure to, you know, UI elements, whatever this particular application does to create user interfaces. Helium, the reason I wouldn't just use /*, the reason I would want this part is because just because I'm I might still want regular comments, right? Like the beginning of the file, for instance, might still want something like this where I like mark what this file is about and hopefully remember to put down the date when I created the file before I forget, which apparently isn't what happened with this file. But, you know, I don't necessarily want this to be the beginning of a documentation string every time. Yeah, I'm not saying this is what I'm gonna build. I'm just making an example of sort of what I would make it look like. I don't really care if this matches. I don't really care if this matches what people do. Yeah, but I also don't want to have to parse ahead, right? So this might be rare, so you might be able to go, oh, this block is a documentation block because I see an @ What if I don't have any parameters? Then I need to, make sure all of these have an @ I could say that documentation strings begin like this and end like this, I suppose. Or they could end like this and begin like this. So there's a bunch of ways I could do it. But I don't really care about getting the details just right. That's not really the point. And I certainly don't want to have to parse ahead to find out that there are ats inside the block just to find out that it's a documentation string, because if I have 10 comments and 5 of them are documentations, then that means I have to parse the other 5 for no reason except to discover that they're not useful, right? So, yeah, this is just syntax, not that interesting. By the way, while we're talking about this, since we're talking about it a lot, I'm going to point out this is so important. Don't overthink about programming language stuff, right? This is a programming language overthinking kind of thing, right? Thinking about syntax, getting all interested in the layout of the text. I mean, it's important to think about how we construct our interface, and when we design a language or a parser that parses text files, we are actually designing the interface for constructing software. But you're always going to be within those limits of a text file. So don't like, if you start to get to the point I'm at with my attitude towards text, you realize that like micro optimizing the text interface is a lot of work for diminishing returns. So just don't think about it too much. Put text language details out of your mind. At least, you know, maybe if you have fun with that, I don't mind you doing that on your own time. Around here, it's not on my mind. I don't like thinking about it. I don't like talking about it. It seems strange to me to get bogged down in that kind of thing. So that is how I would structure it. This would be a lot cleaner, I think. At the very least, it wouldn't have to have this crazy, like, we parse here, generate some text files that are included in different places. There are 2 different ways to reconstruct the data structure again. There's a separate program for checking. The documentation is handwritten in separate files from the API. All of that is busted. And then finally, these 2 things work, but their way of actually grabbing the data is rather cumbersome in both cases. Either they're parsing out that master list again, or they are running the constructors. So yeah, yeah, I think that a better documentation system was possible in 4coder, and I think that's a good place to stop for today. So we took a look at two big things. We started with the website rendering problems and talked about how there are sort of all these problems that converge together to make it so that the website doesn't actually compile. There's two separate versions of the memory system, one for when you have platform abstraction available, one for when you don't have it. And you can only use one of them at a time. And you can only use this one if you're actually inside of the 4ed app compilation target or the custom layer compilation target. Otherwise, you're on these ones for things like website rendering. But then there are some shared pieces of code that want to live in both contexts. And so without a static abstraction that actually solves the problem, this just doesn't work. You have to pick one or the other, and the other one is busted all the time. That's just what happens. And then the second thing we've been looking at is, since we had been looking at the render website stuff, we ended up chasing down this rabbit hole of how documentation was being organized, and found all of this, which we've been talking about up until now. So thanks for coming to check out 4coder Friday. Today, again, I'm not committing to changing 4coder, but this does inspire me to think again about this problem of maintaining documentation in a large project. Maybe an interesting project to attack in the future. I could see how that could intermingle with my object file stuff. If I know how to read and generate and deal with object files, and I know how to parse out documentation strings from a source file, I can start to imagine creating systems where the documentation for a function lives inside the executable more directly and is more automatic. But we're not going that far yet to build something, just sort of thinking about ideas. There's still a lot of cool stuff to learn about by going through 4coder code. So we'll come back again next week. Next week we'll do, on Friday at 10:30 a.m. Pacific time, we'll do another round of 4coder Friday. We'll figure out more stuff to dig into and see what was and wasn't working in 4coder. And in between now and then, I'll be getting back to working on the PE-COF deep dive project. We're very close to being able to generate object files that are novel, that we didn't have tools to generate before. I think in the next week I'll add in the rest of those features, so come check that out if you're interested in the PE-COF deep dive stuff. And another reminder, next Friday, in addition to 4coder Friday, I'm going to have a special bonus stream in the afternoon around 2 p.m. to talk about the Handmade Network Wheel Reinvention Jam and think about what project I would like to prep for that jam. So if you're interested in any of that, keep your eye out, and don't forget that all of these projects that I've got on display today and that I do on the stream, they're all possible when people like you who are watching go to mrforth.com/membership and consider becoming a supporter or a member. And thanks to everyone who's already looked at that option and chosen to become a supporter. It's much appreciated. And with that, I'm going to wrap up. Thanks for seeing what I'm doing, and I'll see y'all around the internet. Bye.